Alright, welcome back. In this video, we're going to talk about arc length. If you haven't checked out the arc measure, the circle's intro video, I would do that first. This is about arc length, the measure, the length in feet or inches or centimeters or kilometers or whatever it is, some length that we can measure along the edge of a circle. So for example, if I had a circle here, I don't know, maybe its radius of 4 inches. Got some central angle. What I'm really asking for is if I took a piece of string and I laid it across this arc, how long would that string need to be to perfectly go from one endpoint to another? That's what I'm looking for arc length. So some number of inches along this edge, along a curved edge. So here's a problem. A hammer thrower spins 7 times before releasing the hammer. How far did the end of the hammer travel? Well, hammer throw, if you've never seen like the Olympics track and field, a hammer throw is where somebody's going to hold on to this hammer and they're going to spin until they get a lot of momentum going rotationally. And then once they spin enough times, they've got some preset number in their head, they're going to release that ball, and it's going to fly out toward the middle of the stadium. So I want to know if this person spins 7 times, what I'm asking for is, so here's my circle, here's the person, there's the hammer, and I want to know if this person spins 7 times around a circle, how far did that ball at the end of the chain travel? So let's simplify this. How far would it travel in one rotation? Well, what do I really want to know if I'm asking the distance around this circle? What measurement do I want to know for the distance around a circle? I want to find what the circumference is. Which is 2 pi r. So I know it's 2 pi r. What I still don't know is what's the radius. So if this person here, this hammer thrower, is spinning about an axis, if she's spinning in the center of the circle, then the radius of the circle is going to have to be the distance from her body, including her arms, to the hammer at the end. So that's both her arms and the length of the hammer. Now in class, we simplified this to say that that distance was 1.5 meters. So I would find the circumference, 2 pi times r, or 1.5 meters, to figure out what that would be for one spin. So that would be, what is that, 3 pi. So if the circumference is 3 pi, I don't want one spin, I want 7 spins. And that would be 21 pi meters. So our formula here, anytime you're trying to find the arc length, what you're really trying to find is you want the circumference, but I don't want the whole circumference, because typically, like if you look at number 8, I don't want the whole circumference, I just want some part of it. So this is the whole circumference, 2 pi r. What fraction of that circle do I want? Well, I want some part of the circle out of the whole. I want some part. A more technical way to put this would be arc length is going to be 2 pi r times your degree measure, whatever that central angle is, over 360. The whole circle's 360. You want just part of it. So let's take a look at one example here together. I've got 2 pi r is my circumference, which is 16 pi. That would be the whole distance around the circle. But I'm not looking for the whole distance around the circle. I just want this part here. So I need to find out what fraction to multiply 16 pi by to get just that part. And to do that, I will look at the degree measure indicated. So I don't want the full 360. I just want 315 out of those 360 degrees. So I'll multiply my circumference by that fraction. Or on number 9, my circumference, the whole thing would be 2 pi r, or 22 pi. But I don't want the whole thing. I don't want that whole 22 pi. I just want this bold part here. What I really want is 315 out of the total 360 degrees of rotation. And I would do this part in my calculator to simplify. Let's try another one. I'd like you to pause the video, try these, and then unpause and check your work. All right, so you find your whole circumference, but I don't want the whole circumference. I just want part of it. What part? Here I want 150 degrees out of the total 360. And here I don't want the whole 20 pi. I just want 60 degrees out of that total 360. So that's what I'll multiply my circumference by to figure out the part that I really want. Let me know what questions you have, and I will see you soon.